All right, calculus friends, let's set up our notes. Okay, so put the video on pause, and I hope you can see this. Hope it's big enough font size and everything for you. But what we're trying to do is we're trying to use what's called the product rule. The product rule to calculate the derivative of a function. So what we were doing yesterday after the test, or the day before when I assigned section 4.1, was we were doing a little investigation on Desmos. Okay, so I'm going to zip over to Desmos here and I'll refresh your memory. We had these two trig functions multiplied together, and our guess was maybe initially, let's just take the derivative of the first function, let's take the derivative of the second function, and see if it matches up with the numerical derivative, right? So this is the numerical derivative. This is our derivative function that we're trying to generate. And man, I've been really impressed with how you guys have been checking your answers more or less, right? Does the green function match up with the blue function? Well, obviously it doesn't, right? Here's the numerical derivative. Our algebraic derivative should fit right on top of this numerical derivative, but it doesn't. So what's going wrong here? And I don't know that anybody would be able to just guess at it by just modifying this a little bit. So I'm going to help you a little bit. Let's add a plus sign in here. So I've got the derivative of the first function. I got the derivative of the second function, right? Let's take the derivative of the first function times the second function. So I'm going to rewrite the second function in here, not modifying it at all. Okay, so if it looks like I modified it, there's a typo. All right. So I've got the first function's derivative times the second function left alone. Now I'm going to take the derivative of the second function, zoom out here if I can. There we go. And I'm going to multiply the derivative of the second function times the first function left alone. So let's see, 3 cosine of x, and holy moly, they line up perfectly right on top of each other. So in our notes, I want you to add something like this. Put down, because I was going to copy it out of the book, but the digital copy of our book looks really messy at this point. So you have two functions, a u function and a v function. And what we want to do to take the derivative of this product of two functions is we're going to take the derivative of the first one and leave the second one alone. So the derivative of the first one times the second one just left alone, plus the derivative of the second one times the first one left alone. So these little tick marks mean I'm taking the derivative of the u function. Just like you saw back here on Desmos, I took the derivative of 3 cosine x, that's negative 3 sine x. Remember the coefficient out front's just riding along, right? And then you take it times the second function just left alone, plus the derivative of the second function, 2 times the sine x, derivative of sine x is cosine x, right? And then the first function just left alone. And this is definitely our algebraic derivative. I've got a little proof for you. I'm going to zoom in over here. Let's just talk some notation for a second. This is the definition of the derivative, like a little change in x, and then you've got u plus a little change in the y value of the u function times v plus a little change in the y function's v minus u times v. So if that doesn't look like the definition of the derivative, remember we had something like this, the limit as h approaches 0 of f of x plus h. You could zip past this proof if you're not interested in it. I'm going to do a couple examples coming up, okay? All over f of x, all over h, right? So this is kind of like our h right down here, okay? And then this right here is the f of x function, because our f of x function is the product of two functions. Remember, f of x equals u times v. That's what's over there in our notes. I had a y here. Y equals u times v instead of function notation. So then over here, what do we got going on? We've got kind of like the v function plus some small little h, kind of. It's kind of like an f of h, really. So it's like f of v plus h, kind of. It's a little tricky, isn't it? And then this is kind of like f of u plus h right over here, and we're multiplying the two together. So anyways, this proof works out like this. Come on, let's see if I can modify my little box here so we can see everything going on. Well, you have the distributive property. So we distribute each one of these terms over through there. And then look, u times v and minus u times v, those guys drop out. Anytime you're doing one of these little proofs, anything without an h in it has to go away. Now, I know this doesn't look like an h, it's delta v thing and the delta u and all that kind of stuff. But this is what we're left with now. And then we're going to divide the delta x into each one of these three terms in the numerator. And as we look at this in greater depth, they kind of break it apart like this. And you can see this delta u right here. That guy right there is going to 0 because as delta x gets really small, delta u gets really small as well, but it's not being divided by something really small. So this is going to 0, and so that's gone. This third term is gone over here. And what we're left with, there's the 0 right there. And they changed the notation a little bit to infinitesimal small little slices of x. And now we've got really the derivative of the u function times v left alone plus the derivative of the v function times u left alone. Now, I know they have them in a little bit different order here. I can't tell you why. I don't know why they don't just put the u over there, but whatever. It's the same thing. There's the product rule right there. Okay, so here it is over here. Hopefully you got that down in your notes. Now, let's try an example together. This comes straight from the book. I'm not going to lie to you. I just copied it out of the book, and I'm hoping I can make it clear to you how this is going to work in a quick and efficient way. So we take the product of, first I take the derivative of each one of these functions. So what's the derivative of x to the fourth? 4x cubed. Let me make a little note of that. Okay, so the derivative of this guy right here is 4x cubed, right? You're going to see that in this problem. And the derivative of cosine of 6x is going to be negative 6 sine 6x. Okay, so we got a chain rule going on. We got the derivative of the cosine function. There's a lot to keep straight, isn't there? And so now we're going to multiply the 4x cubed times the cosine 6x. See how the cosine 6x is left alone? And we're going to multiply the x to the fourth times the derivative of the negative 6 sine 6x. Now, they put the 6 at the end. That's totally fine. And we simplify if we can, like, move the 6 out front, move the negative sign out front, and all that jazz. I hope I'm making that clear. That one, right, is not that much simplification. On this next one, there's a whole bunch of simplifying, and it can get a little confusing on the simplification part. All right, so let me just go over that real quick because this could cause us problems. All right, so what do? We take the derivative of 3x minus 8 to the 7th power. There it is right there. Let me try highlighting it. Okay, so let me turn my highlighter on. And this is not the world's greatest highlighter, this guy right here, but it's better than nothing maybe. So this right here is right down there as its derivative, okay? And the green function here is left alone in this part right here. But its derivative is right, where is it? Where's the derivative? Where is it? It is right here. Sorry. I lost my train of thought. There it is. So there's the derivative of the green function. Here's the derivative of the gold function, right? The other stuff, I guess I gotta extend out that yellow part just a little bit further because the 3 is part of the derivative, right? The other stuff is the original functions just copied down. Nothing's happening to the original functions, okay? They're staying right where they were. So here, this original function right here is right there, not messed with at all, right? And this original function here is right over here, not messed with at all. Now, the author feels like we need to do some more simplification. So when you start looking at it, you see some common factors. And some of the common factors that you see are 3x minus 8. There's 6 of them in this term right here. And there's 7 of them over here. So we can take out at most 6 of them, 3x minus 8 to the 6th power. Right here, there's 5 factors of 4x plus 9, and there's 4 factors of 4x plus 9 over here. So they're going to take out 4 factors of 4x plus 9. Now, what is left in this term right there? Let me put a little different colored underline, like maybe a black underline under this term. What's left after we factor out 6 of these guys and we factor out 4 of the 4x plus 9s? Well, there's one 4x plus 9. See, there's one of them right there. There's one of them. And 3 times 7 is 21. So there's the 21 right there. So now notice this square bracket. Because we factored out some factors here out front, we've distributed some factors out front, we have whatever's left of this term right there. And there's a square bracket saying if we were going to redistribute it, which we're not going to, but if we were going to, we need to end up multiplying all of this stuff by that stuff right there. Now, what's left over here? Well, there were 7 of these 3x minus 6, 8's, 3. There were 7 3x minus 8 factors. I've just taken 6 of them out, right? So 6 of them are over there, but there's still one of them right there. There's one left of those guys. And there's a 5 and a 4, which makes 20. So there's the 20 right there, right? And then there's no 4x plus 9s left in this term because all four of them right there moved out front right here. So the author doesn't feel like we're done yet. Like this factor here is as simple as it can get. This factor here is as simple as it can get. But we could distribute the 21 through. We could distribute the 20 through and do some simplifying. So if we had 21 4x's and 23 x's, let's see, that is 84. Let me write that down right here, and then we're going to compare the author's answer. Okay, so 84 x's there, and we had 60 x's over there, and we're adding them together. So 60 x's plus 84 x's gives me 144 x's, I think. And then I've got 21 times 9, which is 189. So then I got 189. And I got 20 times 8. Now that's a negative, so I get minus 160. So I've got 189 minus 160 is going to give me 29. So let's see if we have 144x. Boy, it's a lot of pressure on me. I hope I didn't make a mistake. Let's see if we got it right here. Got to move this out of the way. Sure enough, 144x plus 29. That's where this other factor comes from. These two factors are as simplified as they can get, but this third factor wasn't simplified. So that's what the author is doing right down there. Now you have a few of those problems, and I left them in the assignment. I know they can be a bit of a pain, but I think part of taking calculus your senior year is to help build some of these algebra skills that maybe are a little rusty, knock the rust off. So I appreciate you watching my video, taking some notes, and I hope that was helpful.